Today we're going to be looking at the MAP sensor and MAF sensor at different waveforms, voltage readings, and other aspects. We're going to start on the 07 Lucerne MAP sensor. Here you can see it's a 3-wire sensor. These are the 3 pins to the sensor of 3 different circuits: a voltage circuit, 5-volt reference, a signal circuit, and a low reference circuit. Here's the MAP sensor on the intake of the Buick. Here we are measuring the 5-volt circuit at pin C of the MAP sensor. Here we are measuring resistance across the MAP sensor at atmospheric pressure. And here we are measuring signal circuit at pin B. Here we can see a waveform of the MAP sensor as RPMs and load increase and decrease. And here we can see on the scan tool as it interprets the voltage readings between a high load and high pressure and low load and low pressure, and converts it into inches of mercury.
Alright, so now we have a vacuum gauge set up on the MAP sensor, and we're going to apply vacuum to it and then watch as the voltage changes on our signal wire. See as we give a little bit of vacuum, there's about 10, 15, 20. As you can see, our voltage goes down. When we release the vacuum, voltage goes back up. Here you can see with the sensor unplugged the default values.
Now we're exploring the MAF sensor on the Buick. Here we can see the MAF sensor is a 5-wire sensor with the IAT integral as part of the sensor. We can look at all of these circuits as the 12-volt for the MAF, the signal circuit for the MAF, the ground for the MAF, the IAT signal, and the low reference.
Now it's only on key on. We're gonna turn on the engine. Now we can see our hertz is going up with the engine on, and now with some revs on the engine, it's going higher. As you can see, the engine load is basically exactly the same as the MAF.
Here is the waveform with the vehicle off. Now you can see as the vehicle's running, the frequency increased and the duty cycle got smaller. Give it revs. Now as RPM increases and airflow increases, you can continue to see how the frequency changes.
The MAF is unplugged, and we can measure. It didn't go up, and basically we don't have any measurements in either hertz or yeah.
Here we're going to look at the MAF sensor on the 11 Equinox. Here you can see it's another 5-wire sensor with the IAT integral. Mostly we're going to be looking at pin A, the MAF signal circuit.
Here we have the signal wire of the MAF sensor. We're measuring the hertz with the key on. You can measure, or you can see the frequency as it sits. Go ahead and start it. We went up to 2,700, 2,500 when it started. and we can switch to duty cycle and see a 47, about 50% duty cycle. There you can see the frequency increasing. So now we have our picoscope set up to our signal sensor, or signal wire of the MAF sensor. You can see with the engine off what our frequency is. Alright, here we have a 2011 Equinox connected to the signal of the MAF sensor. Yep. This is a air density unit, so it only uses a MAF sensor, not a MAP sensor. Here you can see the frequency increasing as RPMs increase.
Goes off.
Alright, go.
Okay, so now we disconnected the MAF. We're gonna start it. We'll got a little voltage. Then we have nothing. Even no engine load, so
On this Cadillac CT5, there's two MAF sensors. Here we are going to sense both signal wires coming out of the MAF sensors.
Here is all the live data for the Cadillac. You can see the intake air temperature, ambient air temperature, both of the mass airflow sensors, engine load, the throttle, and other boost pressures, including the MAP sensor. We can start the motor. We can see as values change. When I give throttle, you can see as the grams per second for the intake also increase. This is the Cadillac CT. You can see both of the MAF sensors. As you can see, the frequency decreasing as RPMs increase. Cool. Yeah. Yeah. Here we can see the blue line is our MAF sensor, the yellow line is our MAP sensor, and the green line is our throttle position sensor. We're increasing throttle. You can see the MAF sensor, the frequency getting closer, the manifold pressure increasing, and the throttle as it increased. Yeah. Here is normal operation of the Equinox. You can see engine load, engine speed, intake air temperature, manifold absolute pressure, the mass airflow, short-term fuel trims, and throttle position. Now with a severe vacuum leak, you can tell a difference in the operation of the vehicle, especially at idle. And how it's affecting fuel trims, and how the mass airflow is reading.